Okay, so welcome. Let's give this a try. First video lecture going down here, so we'll see how it goes. So I want to remind you, my name is Peter, and today is 25th of August. So this first lecture, what we're going to talk about is defining some terminology. So this is the very first section in the book, and I'm going to just go over what the book has in it. So today, we're talking about terminology. So the book breaks down our subject matter, which is the mechanics of energy systems, into three main categories. So I'm gonna do three categories here. Okay, the first category is thermodynamics. So, remember I mentioned this on Monday. This is the traditional name of this course. And it's because this is in some respects the most underlying principle. This defines everything else that we're going to be studying. Thermodynamics itself is based around 4 laws. They're sometimes called the 0th, 1st, 2nd, and 3rd laws of thermodynamics. So thermodynamics is the kind of basis of all of fluid mechanics. That's how I want you to think of it. And we're going to keep in mind that there are 3 laws governing that, and we're going to have lectures on each one of these coming up. Okay, so that's kind of how that's broken down. By the way, this thermo right here, oh, there's a typo. Thermo right here, this comes from the Greek word therme, which means heat. And I'll write down that that's Greek, okay? So thermodynamics is the study of heat. And like I said, okay, that's underlying it. I don't want you to get confused with this next subdivision, which is heat transfer. So, what is the difference between heat transfer and thermodynamics? If therme from thermodynamics means heat, then why do we have heat transfer as a different category? Well, here's the reason why. Thermodynamics itself, thermodynamics proper, it keeps track of energy in all of its various forms. And we're going to talk about how there are different forms of energy. Heat itself is just one form of energy. So that's one distinction. Another distinction is the fact that thermodynamics generally doesn't care about the processes that energy has to go through to transition from one state to another. So we might say that we have 2 systems here. And thermodynamics would say, okay, there's a law, and we're going to follow this law, and it's going to tell us that, boom, some energy comes from this system to this system, and we can put an amount of energy on it. Let's say maybe it's 1 joule of energy, okay? This is how much thermodynamics tells us. Heat transfer is the side of things that comes in and says, how did this energy get from here to here? For instance, a question that thermodynamics doesn't answer, but heat transfer does answer, is how much time did it take? Okay, I use lowercase t for time. Okay, so thermodynamics, again, big picture, foundational. Heat transfer is more about the specifics of what's actually happening. Now, in heat transfer, there's a couple buzzwords that I just want to write down. It's about rates, like with time. Rates changes, things that are changing. And in general, I'm going to say non-equilibrium. So hopefully I spelled that right. Okay, non-equilibrium. This means that things are dynamic, things are moving, things are changing. Equilibrium would be stagnant. So thermodynamics might say, okay, you have one stagnant system, and then boom, you've got another stagnant system. Whereas heat transfer would say, no, let's talk about what happened in between, okay? So the third major category here that differentiates itself from the other 2 is fluid mechanics. So, first of all, defining terms, I should do that. Mechanics comes from Greek, and it basically means studying things under the effect of forces. Okay, so I'm not going to write all that out, but when you hear mechanics, it has to do with forces. Thermodynamics and heat transfer don't necessarily have to do with forces. Fluid mechanics does. This is why it's a distinct category from the rest. So, but I do want to say, as a note, even though these categories are distinct, and for the purpose of sort of organizing our brains, we're breaking them down like this, all of these things are found in real-world systems. And we're going to need to learn about all of these areas in order to do calculations for real-world systems. So, for example, the textbook uses the example of a car engine. So, thermodynamics would tell us how big does the radiator need to be? What is the amount of energy that we're dealing with here? Heat transfer would say, okay, now that we know how big the radiator needs to be, how big do we need the inner diameter of the pipes to be, and the fins, and everything like that, so that we can practically get that amount of energy through the radiator? And fluid mechanics would say, all right, now that we know how we're getting it there, what forces do we need to apply to that fluid and how? So this might come in when we're trying to pick out a pump, for example. What water pump do we need? How many newtons of force does it put on that liquid to get through the pipes that we've sized correctly for our correct size radiator, okay? So in the real world, they all work together, but that's kind of an example of how they break down. The last thing here is that fluid mechanics itself is sometimes broken down into two categories, and really all of engineering is broken into these two categories. Statics, which are things at rest. There are a few exceptions, but things that we can look at in terms of being at rest. So we'll get to this, but what's called an inertial reference frame, okay? There's a few instances where things may be moving nicely and we can still deal with statics, but mostly it's at rest. Dynamics, on the other hand, this comes from dynamis, which means power in Greek, okay? So this was their word for things that are moving. And this motion can be as crazy as we want. It doesn't have to be nice at all. Anything, no matter how weird and wild and wacky it is, if it's moving and there's forces applied on it, it falls under the category of dynamics. So I'm just gonna say moving, okay? So this is the terminology. This is kind of how our book breaks it down. And so next lecture, we're maybe gonna look at some units and how we can start practicing unit conversions. So thank you guys.